Hello, my name is Akash Persaud, and I'm an RU student for the National Science Foundation and NOAA CREST in satellite and ground-based remote sensing. The title of my project is Observation of Aerosols and Characterizing the Planetary Boundary Layer using instruments such as Ceilometers, LiDARs, and sun photometer. Before I get started, I would like to give a big thank you to both of my mentors, Dr. Mark Aren and Dr. Fred Mashari of the City College of New York. This project is a study of regional ozone pollution, as well as measurements of the various precursors leading up to the formation of ozone. Ozone is created when a chemical reaction between oxides of nitrogen and volatile organic compounds mix in the presence of heat and sunlight. Ozone is a primary concern for young people, the elderly, and people who suffer from diseases such as asthma, as it can harm lung tissue. In order to tackle the regional air quality problem, various instruments such as trace gas analyzers, CMELs, and Ceilometers are used to gauge air quality. Ozone in the Earth's lower atmosphere or troposphere can be formed from pollutants released into the air from car exhaust, refineries, and factories, to name a few. Throughout the day, the surface air is mixed within the planetary boundary layer through convection as the Earth's surface heats up. Our goal is to identify aerosols and the precursors of ozone and their effect on downwind areas such as the New York metropolitan area, Long Island, and Connecticut. We're also interested in how heat waves impact the regional air quality. With a better understanding of the air quality around us, we can promote cleaner, breathable air. Ozone is a concern for residents of the tri-state area and Connecticut. The planetary boundary layer, also referred to as the atmospheric boundary layer, is the bottom layer of the troposphere that comes into contact with the Earth's surface. The height of the planetary boundary layer is not constant. During the day, and particularly in the summertime, the height or thickness of the planetary boundary layer increases. Conversely, at night and in the cooler seasons, the height of the planetary boundary layer decreases. Aerosol emissions increase during the day. As the sun heats the Earth's surface, the convective air and cooler air residing above the planetary boundary layer create a mixing effect. Higher wind speeds induce more mixing. Pollutants such as oxides of nitrogen and volatile organic compounds mix in the planetary boundary layer where they react in the presence of sunlight and heat to form ozone. The ozone then gets mixed back down into the surface air. Our methodology included the deployment of the various instruments, in particular 2 locations. So we did deploy the instruments over CCNY's campus, as well as Northport, Long Island, and Sherwood Island State Park. 2 Ceilometers were deployed, one in City College's campus and Northport, Long Island, and 2 Doppler LiDARs were deployed, one in City College campus and one in Sherwood Island State Park, Connecticut. These plots were generated using MATLAB and Python algorithms. If we go over here, we can take a closer look at the wind profiles generated. So the wind behavior has had an effect on the transport, actually. The data analysis from the wind LiDAR can help to show how easily pollutants move across a given region. Figure 1 here shows a time series of vertical wind speed profiles. It's a figure of height versus time. And it's also color-coded with the vertical wind speed. This shows that there is a lot of mixing and vertical transport of ozone as well as NOx and VOCs. Figure 2 is a variance plot that shows the turbulence statistics of figure 1, indicating where there's more or less turbulence and mixing. Now let's take a look at Ceilometer data taken from 2 different environments, a coastal one and an urban one. So Ceilometers send pulses of light through the atmosphere and help us analyze backscatters from aerosols. The Ceilometer backscatters show that early morning, around 6 a.m., there is not a lot of aerosols. However, closer towards the middle of the day, as the Earth's surface starts to heat up, we see an increase in the concentration of aerosols below the planetary boundary layer. Here we have CL31, which represents the backscatter in Northport, Long Island. Here we have CL51, which represents the backscatter at CCNY's campus. With this comparison, we can see a huge difference in the planetary boundary layer dynamic in an urban environment versus a coastal one. Here we see that there is a lower mixing layer height where there's going to be higher concentration of ozone. So throughout the Listos campaign, we can help better understand how pollutants are mixing in the atmosphere. While ozone levels have been decreasing over the years, the ozone concentration still exceeds the national ambient air quality standards. With a better understanding of regional air quality, we can help to promote cleaner and breathable air.